Hello everyone, good morning. Today we are going to study a new topic, that is Archimedes principle and buoyancy. So as we all know from our school days that we have studied this Archimedes principle and buoyancy. But what is the real mechanism behind it? Today we will see about in more details about it. So let's start about. So basically, what is Archimedes principle? So Archimedes principle is a fundamental concept in physics that explain how objects behave in fluid. So basically this presentation explores the principle of the buoyant force and the real world application. So we can see that how the Archimedes principle works basically depends on the thrust and the gravity. So next, the main principle of Archimedes principle states that an object submerged in a fluid experiences an upward force equal to the weight of the fluid in display. So the body, when it experiences basically an upward force equal to the weight of the fluid when it displays the fluid, then that is the main principle of Archimedes. So now let us consider an example for better understanding of the concept Archimedes principle and the buoyant force. So here in this picture we have applied a load in the air medium of weight of 7 pound, and then we have immersed the load in the water. When we immerse the load in the water, some of the water have displaced from the beaker. So basically a upward thrust is produced when we immerse the load, which is equal to the weight of the displaced water. So this picture tells that the buoyant force is equal to the weight of the displaced water. So we can clearly understood from this picture what actually tells about the Archimedes principle and the buoyant force. So here also, in case of a ball and a hull, the displaced water weighs less than the ball. In case of hull, where it compress water, displaced water weight equal to hull weight. So these are some examples of Archimedes principle. We can say that. So here is our main Archimedes principles, some theory base. It says that an object is totally submerged in a fluid of density rho fluid, and the volume V displacement of the fluid is equal to the volume of the object V equal. Then the upward buoyant force is B, mainly rho fluid into acceleration into gravity into velocity of the object. And we know that the downward gravitational force is Fg equal to mass of the body into acceleration due to gravity is equal to rho of the density of the object into acceleration of gravity into velocity of the object. So the net force will be Fg equal to rho fluid minus rho object into g into velocity of the object. So here basically this is a mathematical analysis of Archimedes principle. So in this slide we can see the graphical approach between the brass and the aluminum. So here in case of brass we have got the graph between submerged volume and time. So we can see that submerged volume and the buoyant force. So it is a submerged volume in the x-axis and the buoyant force in the y-axis. So in case of brass the graph look like this, and in case of aluminum the graph between the submerged volume and the buoyant force will look like this. Basically it is a linear curve. So with the increase of the submerged volume the buoyant force also increases. So it is a directly proportional to the submerged volume and buoyant force. So this is basically a graphical analysis of different metals. So now we come to the buoyant force. So the buoyant force is the actually known as the upward force exerted by a fluid on an object. When we sink an object in the water, the object experience the upward force exerted by the fluid. So that is called actually the buoyant force. It determines whether an object floats, sinks, or remains suspended. So you can see the picture clearly shows that the buoyant force in the fluid, where the gravity also act the object, and the fluid exert a buoyant force. Buoyant force is also equal to the difference between the weight of an object in air and the weight of an object in air. So it basically explains this picture only. When we sink an object in the fluid, it is the equal to weight of the object inside the fluid and with the object in the air. So Fb equal to weight in the air minus weight of the fluid. So in other words, the apparent loss in weight of a body immersed in a fluid is equal to the weight of the displaced fluid. So now for floating object, buoyant force Fb equal to Fg displaced equal to mfg, which the mf refers to the mass of fluid displaced. Again for floating object, the Fb, that is the buoyant force equal to force of the object equal to mass of the object into acceleration due to gravity. There are some key factors in buoyancy. They are density of the object. As we know, density of the object is the main concept in the buoyancy. Also the density of the fluid, volume of the displaced fluid. When we sink in the object in the fluid, the volume displaced by the object in outside. This is the volume of displaced fluid. Floating and sinking. So it is basically related to the buoyancy only. An object floats if its density is less than the fluid density. So when the object weight is less than the fluid density, it basically floats over the fluid. It sinks when the object density is greater than the fluid density. So basically the object sinks inside the fluid. Now the mathematical formula of the buoyant force is buoyant force Fb equal to density of the fluid into gravitational acceleration into volume of the displaced fluid. It's basically indicates the formula of the buoyant fluid, so we can calculate in the numericals and all. F equal to rho g into v, where rho is the density of the fluid, g is the gravitational acceleration, and v is the velocity of the displaced fluid. When the object sinks in the displaced volume, it's called the velocity of the displaced fluid. We can also relate the buoyancy in some real life example, such that ships, boats floating on water, hot air balloons rising in the air. So basically the concept of ships and boats floating on water, hot air balloon rising in the air, and submarine driving and surfacing. These are some basic real life examples of the buoyancy and Archimedes principle. Archimedes discovery. So basically Archimedes reportedly discovered the principle of taking a bath. So it is a coincidence, I would say. So he noticed the water displacement and exclaimed the word Eureka. So from here he discovered the theory Archimedes principle. Some are the experiment to demonstrate that submerging object. So actually these are the experiment that you can demonstrate the mainly the buoyancy and the Archimedes principle. So we can these are the experiments that we can show that the Archimedes principle and the buoyancy in a real life. So submerging object in water to measure displaced volume. So we can in a beaker we can pick some object and sink it to see the displaced volume, or we can even measure it also. So and even we can using a spring balance to measure the buoyant force. We can use a spring to measure the buoyant force also. Observing floating of the various density, we can see the various object in the floating of various density in ocean, in various whatever you can see this. So these are some actually we can show that the buoyancy and the Archimedes principle. Now in this slide we will see the applications in engineering. So basically, what are the applications in the engineering of the Archimedes principle and buoyancy? There are different types of application. First one is the designs of ships and submarine, development of aerostats and balloon, understanding the fluid dynamics in pipeline. So these are some examples. Actually, there are many example application of the buoyancy and the Archimedes engineering. So some of these are, we can design ships and submarines. So the principle of buoyancy, about taking the densities or whatever calculation we needed, and understanding the fluid dynamics in pipeline. In pipeline also we can use the concept of fluid dynamics and pipeline. You can see the buoyancy. We can also use the concept of buoyancy in the pipelines. There are some limitations of this principle. For first principle is that we have to assume the fluid is incompressible. So there is a first limitation, that the fluid should be incompressible in nature and does not account for fluid viscosity. So the fluid does not should have the fluid viscosity. This is the main concept of the buoyancy and Archimedes principle limitation. So we have to also neglect the surface tension effect in the case of buoyancy and Archimedes principle. So this is the what Archimedes principle and buoyancy concept. Thank you.